Hi, today we're going to talk a little bit about quadratic functions and what they look like on a graph, some characteristics of these functions. This is part of algebraic reasoning, level 1 of Unit 1B. It's identifying characteristics of a quadratic function. When we're looking at a quadratic function on the graph, it usually looks like this, like a smiley face, or a mountain. One of these two looks like this. And the shape is called a parabola. Here's the word parabola. And it might help to have a couple of highlighters handy if you would like to mark some things for you. I'm going to be marking some things here in a minute. The function has a minimum, like I said here, a smiley face, or a maximum, a mountain. The mountaintop has a peak, and the smiley face has like a low spot right there. So that's what you look for is the minimum or the maximum. And wherever that minimum or maximum is, here or here, we call it the vertex. Vertex. Okay, so the vertex is like the highest point or the lowest point of your parabola. And the vertex determines the axis of symmetry. Now, what I'm going to do here is I'm going to go ahead and highlight this part that says axis of symmetry. It's not very clear. And then I'm going to come down here, and I'm looking at this particular quadratic function right here. And I see that the lowest point, the minimum, is at -1, -5, and if I were to draw a line right through here, it's the axis of symmetry. That means if I were to fold it over right there, it would exactly lay on itself and look like one line if I could fold it over and do that. So that's the axis of symmetry. And over here, my axis of symmetry falls right where the maximum is. And the maximum is at 3, 0. So remember, I count on the x-axis first, 1, 2, 3, and I don't go up or down, so it's at 0. And I'm going to draw my axis of symmetry right there. Okay, great. Okay, now we have some special names for some other parts of the quadratic function, and one thing that we're really concerned with are solutions, and we call solutions by different names. Sometimes we call them zeros, and sometimes we call them roots, and sometimes we call them x-intercepts. But all three of these things are all names for the solutions to the quadratic function. Okay, so when we say this, you're saying, okay, well, what does that mean? Well, we know that a y-intercept is where a line or a function will cross the y-axis. Well, the x-intercepts are where the function crosses the x-axis, where it intercepts it, where it stops it. So what we're going to look at right here is we're going to fill this in and say the solutions are, scratch to that, the solutions are where the parabola crosses, and it should be crosses the x-axis. Okay, so this is like an extra space here. This shouldn't even be here because it crosses the x-axis right there. A quadratic function can have 1, 2, or no solutions. Like this right here, this example right here, I'm going to go ahead and I'm going to put my x-intercept, I'm going to highlight it in blue along with roots and zeros, because right here are x-intercepts where it crosses the x-axis. Now this particular function has 2 roots or 2 solutions, 2 x-intercepts, okay, and I have highlighted those in blue for you because that's where they cross the x-axis. But let's look over here. This one is only really intercepting or touching that x-axis at one point. So it only has one solution, okay? If the parabola were down here and the maximum were down here and didn't intercept the x-axis, we would say it had no or zero solutions. So let's look at the questions and see what we can come up with. Does this particular function have a maximum or a minimum? Well, it has sort of the smiley face, and so the smiley face means it has a minimum. It has a low point. So you can always abbreviate that as min if you'd like. And the axis of symmetry. Now the axis of symmetry is a line. So to identify the line, we have to name it by using x equals. So this is x equals, and in this case, this is my origin, so this is -1, so it's x equals -1. I don't have to give it a y value at this point because it's just the axis of symmetry, just that line down the middle. Now the vertex right here, I am going to give it a value because it is a point, okay? The axis of symmetry is a line, but the vertex is a point. So I'm going to say that it is right here at this point, so I'm going to name it by using ordered pairs. So I'm going to say -1 because I travel -1 on the x-axis first, so -1, and then -1, -2, -3, -4, -5, -5. So my vertex is at -1, -5, because it's an actual value and point. There are two solutions. There are two solutions right here for the function, and those solutions, because they are solutions and we know that solutions are on the x-axis, we can just give them the value. So the solutions are -2, -3, -4. So it's -4, comma, and 1, 2. Now we can just put those in braces if we want. We don't want to put them in parentheses because parentheses would indicate that it was an ordered pair. So the braces is just like, here are the braces and here's some lists of numbers in the braces. So the solutions are -4 and 2. And those are the values along the x-axis where that function intercepts it. Now how many zeros does it have? Well, the zeros are the x-intercept, so it has 2. It has 2. Knowing that, let's go over here to the second example. Does it have a minimum or a maximum? Well, it has sort of a mountain look to it, so it has a mountaintop or a maximum. Maximum, and I'm going to use the abbreviation MAX for that, maximum. And the axis of symmetry we have already identified with this pink highlighter, so it is at x equals 3. Now remember, we're calling it x equals 3 because it's a line, and it's every point along in the range of y. So it's in every point of that. So we're just going to say x equals 3, so we know that that's a line. But for the vertex, let's go ahead and name it with an ordered pair. And the vertex is, of course, 1, 2, 3, 0. That's because in an ordered pair, of course, we have x and y. This is the order it is. So your x, what's on the x-axis, comes first, and then the y. So we go across to 3, but we don't go up or down, so it's 0. So 3, 0. Now the solution here is the vertex, because the vertex is just sitting right there on the x-axis. So the solution is, we could just say the solution is, we can scratch that out and just put is, and we can say is 3. Okay, so it's 3. The solution is 3. How many zeros does it have? 1. It just has 1. It doesn't cross in 2 places, it just crosses in 1. So now give it a try on your own and see how you do.